this isn't labeled this way, but this is 3.1. Okay, so we're starting unit 3. This is section 1. We're talking about slope. Okay, I really hope this set of notes is just like a easy review for you, because slope was an Algebra 1 topic. Actually, I think maybe before Algebra 1, I'm not sure. But you worked with slope a ton in algebra. Okay, so hopefully this feels like a bit of a review. Okay, but remember what a slope is, it's really just the steepness of our line. Okay, so the steepness of a line is called slope. Okay, you can see in the little graphic here, your slope can be increasing, okay, up to the right, up to the right, up to the right, up to the right, or it can be decreasing, down to the right, down to the right, down to the right, etc. Okay, so we're going to talk about the different types of slope. Okay, but when we talk about the steepness, I need the side conversations to stop. I should not hear little conversations all around the room. It's very distracting. Thank you. Okay, so when we talk about the steepness, okay, or the biggest or smallest slope, we're referring to the steepness. So the steepest line will have the biggest slope. So of these, which is the steepest line of these three? The last one. Okay, so that is the biggest slope or the steepest line. Okay. When we are finding slope graphically, okay, so if we have a line graphed, the easiest way is to pick some points. So I'm going to mark some points on here. Now you want to pick points that have that go through the intersection of your grid lines. Okay, you're not going to count the slope from like here, for example, because that's not going through an intersection of the grid lines. So you want to pick a couple points that intersect the grid line intersections. So like here is one. You may not pick the same two as me, and that's okay. Okay, and here is one. Okay, so you pick 2 points, and then we're going to count. Now, I always recommend you start from the left. We read a graph just like we read a book, left to right. Okay, now you start with your leftmost point that you picked, and then you're going to count your rise or fall. Okay, up is a rise, down is a fall. My pen stopped working. Oh, rise and fall. Now, what's the difference in rise and fall? Positive and negative. Good. So if you want to put that in parentheses. Okay, so if you're rising, okay, that's a positive unit. If you're falling, that's a negative unit. Okay, so in my graph over here from left to right, I'm going to have to go up 1. So that's my rise, positive 1. And then you find your run. So mine is to the right 2. Now, if you always start on the left, your run will always be to the right. Okay, so this one was rise 1, run 2. Your slope represents your rise or fall over your run. I'm sure you've heard that about a million times. Rise over run, rise over run, rise over run. So in this example, that is 1 over 2. So this slope of 1/2. Everybody good? All right, now here we're going to practice that with pick 2 points on the grid and count and see if you can get your slope. Now, remember, not everybody may pick the same 2 points. So if you get a fraction that's different than somebody at your tables, maybe y'all picked different points and somebody maybe needs to reduce. Okay, because you always need to, if you have a fraction that can be reduced, you want to reduce it. Okay, so take a minute. Okay, try these 3. Pick 2 points and count your rise over runs. Okay, and then we'll come back together and check. So y'all try them, compare to the people at your group, and then we'll come back and check. I'm going to get our attendance put in.
5 minutes ago. That's great. She just wants the slope. No, she just wants the slope. It might be so.
Alright, sounds like y'all may have them, so let's check. Help me and freeze that. Alright. Y'all feel okay about counting slope from a graph? Okay, the only one that I reduced there was this one. It was a, guys, come back together. Stop talking, please. Okay, if y'all have a question, please do ask me, but I need the side conversations to stop. Okay, so the only one that I reduced here was rise 4, run 1. Anytime you have that, if you prefer to leave it as a fraction so that when you're graphing, you have that rise over run, that's okay, but you don't need over 1. Dividing by 1 doesn't do anything. That's just a 4. Okay, any questions over any of those? Okay, so we know that there's 4 types of slope. Okay, so what we dealt with first there was the positive and the negative. We had some of each. Y'all told me this in my rise or fall. If I'm rising and going to the right, it's a positive. If I'm falling and going to the right, it's a negative. So when we are reading our graphs from left to right, if that graph is increasing, and again, the big key part there, the important part there is left to right. Okay, we are always reading the graph left to right. So if it is increasing, if it goes up, I'm going to put the word increasing in parentheses here. Okay, you have a positive slope. If your graph from left to right goes down, meaning it is decreasing from left to right, you have a negative slope. Okay, and then the other 2 types besides positive and negative are when you have a perfectly horizontal or vertical line. Okay, when that happens, if your line is horizontal, okay, I'm going to put that in parentheses, horizontal. You have a horizontal line. What does that mean? What is your slope? My slope is 0. And to help you understand, if I try to count my rise over run, let's see what that would look like. If I pick any 2 points on here, I could pick any 2, it doesn't matter. How far up or down do I go between those? What's my rise between those 2 points? 0. Okay, and what's my run? Why is my pen not working? The run could be anything. In my particular example, okay, you can get your papers, come sit right here. That's fine. Or come sit at this desk. All right. What my run that I picked was a 4. Okay, you could have picked any points. Does it matter what numbers in your denominator? If you have 0 in the numerator, 0 divided by anything is 0. Okay, so that's why it's a horizontal line has a slope of 0. Okay, 0 divided by anything is 0. Now the in the contrast is a vertical line. If you have a perfectly vertical line, if I were to pick any 2 points on here and I go to count my rise over run, my rise could be any number depending on how far apart the points I picked are. Here in mine, I picked 3, but my run is what 0, isn't it? I don't go left or right any. And that's the difference. 0 in the numerator versus 0 in the denominator. Can you divide by 0? So what type of slope is this? Undefined. A lot of people get those mixed up, 0 and undefined. And so that's why I just wanted to show the actual fraction and where 0 is. Okay, so we have, this is vertical, is undefined slope, horizontal is 0 slope. Okay, make sure we understand the difference. Those are common ones to mix up. All right, let's flip over to the back. All right, if you don't have your line graphed, okay, you can't graphically simply count your rise over run. We have a formula where we can do rise over run. Your rise is simply the change in y, because rise is up and down. Your vertical axis is your y axis, right? Your run is simply your change in x, because your run is left to right. That's your x axis. So it's your change in y over your change in x. Symbolically, you may see this is a triangle symbol that's called a delta. It's a Greek letter delta. Have y'all heard that before? Okay, so delta in math means change. So if you see delta y over delta x, that's just slope. That's change in y over change in x. Now, what we would write for an equation, y'all may or may not remember the formula. Change means difference. We're finding the difference in y's. So y2 minus y1 over x2 minus x1. Okay, we practiced labeling points as x1, y1, and x2, y2 when we did midpoint and distance back in unit 1, right? So we label our 2 points and then we plug into the formula. Remember, the formula has a negative. So if you plug in a negative, guys, I need the side conversations to stop. I'll let you pick where you sit, but if you can't control your mouth sitting by your friends, I will move you. Thank you. So when you're plugging in, what I was saying is the minus is in the formula, just like in distance formula. So if you have a negative value for your x or your y and you plug it in, it's okay to have minus a negative. It's going to change to plus. Okay, but make sure that you're not dropping a negative because you see the minus in the formula already. You can end up with a double negative there. So when we go to try it for this example, change in y over change in x. So it doesn't matter, again, which is which, but I'm going to start with my y's. Okay, so 3 minus 1. I'm going, calling the point on the right, my second point. And then my x's, it would be 2 minus negative 4. Now remember, you have to be consistent in your order. Since I put 3 first on top, I have to put 2 first on bottom. If I switched it around, that would have been fine as long as I was consistent in the order, right? Just be consistent. If this is your 0.2 for the y's, then it has to be your 0.2 for the x as well. So we end up with that double negative. I said that it's okay to get, so that changes to plus. So we end up with 2 over 6. If you can reduce your fraction, reduce your fraction. What is 2/6 reduced to?
1/3.
So my slope is 1/3, positive 1/3. Okay, this next section, maybe for some of you, you think, why are we even doing this? This is easy. Okay, and that's great. Congratulations, you work well with fractions. Not everybody does. Some people struggle with reducing fractions, so we're just going to do a quick little practice. And not just reducing fractions, but making sure we understand positive and negative and where that 0 appears in a numerator or denominator, what it means. Okay, so what we said on the front when we were talking about undefined versus 0 slope, it was where the 0 appeared in the fraction, right? If 0 is in the numerator, that's going to be a 0 slope. If 0 is in the denominator, that's going to be an undefined slope. So let's go ahead and find any of those here. Do y'all see any 0 slopes? Okay, so 0 is in the numerator here and here. It doesn't matter if there is a negative on the number that's being divided. Okay, some people are like, well, positive divided by a negative. This isn't a positive. 0 does not have a sign, right? 0 is not positive or negative. Okay, so we don't worry about a sign. We would just say 0. But when 0 shows up in the denominator, like these, again, it doesn't matter if the numerator is positive or negative because you can't divide by 0. Can't divide anything by 0. So this is where we end up with undefined. Now I'm just going to go through the rest of these. I don't see zeros anywhere. So we are going to have slopes other than 0 or undefined. A positive divided by a positive is a positive. A negative divided by a negative is a positive. So just remember, they are the same sign, either both positive or both negative. You end up with a positive slope. If one is positive and one is negative, it doesn't matter if it's numerator or denominator. Like here on the left, we have a negative in the top and a positive in the bottom. Here we have a positive in the top and a negative in the bottom. It doesn't matter where it is. If one is negative and one is positive, what's it going to come out as? Negative. Okay, so I know both of these are going to be negative. That's going to be negative, negative, and that's it, right? All the rest of those have the same sign. Both positive or both negative are going to come out positive. All right, so now let's actually reduce some fractions. 3 over 9, what will that reduce to?
Negative.
No, if it was 9 over 3, it would be 3, but it's 3 over 9. 1 over 3. Okay, good. Negative 1/3. Okay, remember, if you're unsure of reducing, you're looking for what common factor can I divide out of both of these? So both of these are divisible by 3. So I divided 3 out of both. 3 divided by 3 is 1. 9 divided by 3 is 3. Okay, what about 4/10? What common factor can I divide out of both of those? Okay, so if I divide 4 by 2, I get a 2. If I divide 10 by 2, I get a 5. So 4/10 reduces to 2/5. All right, I think we said on the front, anything divided by 1 is that number. It is itself. So that's simply a 4. Okay, we said negative divided by I don't know why I'm skipping one. Same thing here. Anything divided by itself is, or divided by 1 is itself. So this is just -7. Okay, negative divided by negative is a positive. Can you reduce 2 over 3? No, there's no common factors of 2 and 3. So it stays 2/3, but it is positive 2/3. Okay, what about 1 over 8? Can you reduce that? No, it just becomes positive because you have a negative divided by a negative. Okay, can 4/7 reduce? Oh, no common factor for 4 and 7. Same thing here, no common factor for 1 and 8. It just becomes negative. So whether your negative is in the denominator or it's just in the numerator, your slope comes out negative, and you can just write the negative in front of the fraction itself, not within the numerator or denominator. We feel okay about reducing slopes? Okay. So then you're going to try, we're going to do the same thing here that we did on this first one. We're doing change in y over change in x. So if you want to label those as x1, y1, x2, y2, you can do that. Or you can simply do kind of like I do in like color code or circle and box or however you want to organize it. But identify your y's. It doesn't matter the order. So let's say I did the -1 first and then the 2. What do I have to do for my x's? What order would I have to write those in? The same one. I did the -1 first for the y, so I have to do the 4 first for the x's. So I end up with -3 over, and then that is -2. So this comes out to positive 3/2. If you had switched it, 2 minus -1 would have been positive 3, and 6 minus 4 would have been positive 2. So 3 divided by 2, same thing, right? So it doesn't matter as long as you're consistent in the order that you put those. Okay, so if I do that here, in this middle one, -2 minus 3 for my change in y, and then my change in x would be 3 minus 4. So I'd end up with -5 over -1, which would come out to what? Positive 5. Good. All right, if I did this one the other way, I'll show you can still do the second first if you want to. So I could do 12 and then 4. So I'd have to do -3 and then 0. So 12 minus 4 is 8. -3 minus 0 is still -3. So that is just -8/3. Any questions about those? Okay. So change in y over change in x, rise over run. So graphically, you're just counting rise over run. Okay, algebraically, you're doing change in y over change in x. So, excuse me, in these last two, they want us to find the slope, and then they ask us some questions that are going to lead us into our next lesson, but I just want to see who kind of remembers that. But the first thing we need is the slope of the line. Okay, so I'm going to count between those lines, or between those points, I should say, because they've already picked the points for me. So I'm going to start on the left, and I'm going to go down 1, right 1. So my slope is positive, or excuse me, -1, because I went down and to the right. So rise over run, that's just a -1. Okay, for this graph on the right, I go up 1 and right 5. So rise over run is 1/5. Okay, so the questions we want to see if y'all remember, what would the slope be of a line parallel to this line on the left? Okay, so what do parallel lines, what are parallel lines, I should say? Two lines that never intersect. Okay, they're on the same plane, but they never intersect. Why don't they ever intersect? Because they have the same slope. Okay, so parallel lines never intersect because they have the same slope. So the slope of a line parallel to this one would also be -1. Okay, perpendicular. What does perpendicular mean? Intersect at 90 degrees. Remember the symbols? This is the parallel symbol. This is the perpendicular symbol. Okay, the perpendicular symbol looks like a 90-degree angle, doesn't it? Okay, so that'll help remind you what it means if you look at the symbol. Okay, so perpendicular intersect at a 90-degree angle. Okay, so if parallel lines have the same slope, perpendicular lines, do y'all remember how their slopes compare? Opposite is part of it. And what? Opposite means switch the symbol. So positive or negative, that's the opposite part. What else do you do besides switch the sign? You flip the fraction. Okay, does anybody remember what that's called? Starts with an R. Reciprocal. Opposite reciprocal. We're going to talk more about that in our next set of notes. That's okay. But what you need to remember for perpendicular, okay, y'all said opposite. Okay, so that means change the sign. Okay, and then reciprocal means flip the fraction. Okay, so for a -1, what would it be if I found the opposite reciprocal? It would just be +1. Very good.
Yeah.
So the perpendicular slope would be 1. Because if you think of it as a fraction, it's 1/1. When you flip it, it's still 1/1. So the flipping fraction part didn't change anything. It's just the changing of the sign for this one. Okay, so the parallel slope was -1. The perpendicular slope is +1. Okay, but here's one that's actually a fraction. What would be the parallel line slope? Parallel?
Oh, parallel, sorry.
1/5. It's going to stay the same. Now the perpendicular slope, -5. Good. The 1/5 would flip to 5/1. Very good. All right. So now I'm going to go activate y'all's practice over slope. Let me stop this video. Yes, it's a Delta Math. We're back to Delta Math finally. It's not going to be on a worksheet.
Thank you.